How's it going, everyone? Welcome back to the channel. My name is John and I give you regular space updates. And in this video I'm going to be talking to you about how NASA plans to put a permanent base on the moon. So the plan from the American government, NASA and a whole network of international and private partners is bigger than anything we've done before. Because this isn't about planting a flag and then coming back home. This time the mission is to stay, and if they can actually put it off, what we're looking at isn't simply another moon landing, it's the start of something completely new. Building a permanent human presence off Earth. Landing on the moon is extremely difficult, but it's not the main challenge anymore. We've done it before. The real challenge begins after the landing. We have to create the infrastructure, got to create a working base, and basically we have to build the first small city on an alien world. And no one knows for sure how that's going to go. But what we do have now are surprisingly clever and realistic solutions that could actually make it possible. So you're probably wondering, where would we even build a moon base? The moon is massive, and every time humans have landed before, it's been near the middle. Nice flat areas, safe terrain, direct communication back to Earth. But that was in the 1960s. Now we're aiming for something far more interesting and far more dangerous, the lunar South Pole. This region is packed with impact craters, mountains, ancient volcanic areas, and deep valleys that never see sunlight. Some of these crater floors have been in darkness for millions, even billions of years. And that really matters because those permanently shadowed areas could be hiding something incredibly valuable. Frozen water that would have arrived on different comets and asteroids hitting the moon. NASA has already identified around 13 potential Artemis landing sites, mostly along bright zones around crater rims, where you get limited sunlight, but you're actually surrounded by rough terrain. So yes, the science potential is insane, but it's also going to be incredibly risky for humans who are trying to work and survive there for weeks and months at a time. Which means one thing, we're going to need infrastructure that makes Apollo look like a camping trip. Step one, we need to install some kind of roads, because if we're serious about staying on the moon, we're going to need stable landing pads, hard surfaces and safe driving zones, because the moon has a major problem, dust, and not regular dust. The lunar surface is coated in a thin layer ultra-fine dust that's sharp like broken glass, highly abrasive and extremely clingy. During the Apollo missions, this dust damaged suits, scratched visors and caused equipment issues. Even worse, because there's no atmosphere and low gravity, if you kick up dust, it travels far and fast. A perfect example is Apollo 12, when it landed around 180 meters away from the probe called Surveyor 3. The lander's engines basically sandblasted Surveyor. So imagine a real moon base with constant landings, takeoffs, rovers moving around, astronauts walking, machinery operating. The dust would literally become an everyday nightmare. So we need to stop it. So they do actually have a solution for this dust problem, and it's called a rhino shot. This worked when the US government were working in Afghanistan, where the dust was a real problem. So technically it could work on the moon too, but there's a big problem. You'd need to transport huge amounts of it from Earth. And you're basically dumping microplastics all over the moon, and that's basically not scalable. So there is a more sustainable solution, and it's honestly kind of a genius idea. You literally melt the lunar surface into a solid glass-like layer. The European Space Agency has been experimenting with this using simulated moon dust and powerful lasers, and the idea makes sense. Glass is basically melted sand, so why not pave the moon by turning dust into solid ground? Instead of hauling materials from Earth, you use what's already there. Even better, you might need a massive laser. You could use a huge magnifying lens called a Fresnel lens to concentrate sunlight and melt the dust. The lens wouldn't even need to be a gigantic one, around 2.5 meters wide. Because of the harsh geography and long shadows of the lunar South Pole, lasers may still be needed too. The only downside, it's slow. The ESA estimates that building a landing pad around 100 square meters, only 2 centimeters thick, could take about 115 days. So it's not fast, but when you're building a city on the moon, nothing is fast. So transport will also look very different from the Apollo missions. Instead of astronauts constantly climbing in and out of suits, future moon bases will use pressurized rover vehicles. You go from habitat, rover, and then to another module. So Japan is working with Toyota, and they are developing a pressurized rover called the Lunar Cruiser, basically like an RV for the moon. It could support 2 astronauts for up to 30 days, powered by a hydrogen fuel cell. That's how we explore and expand. Now let's talk about where people will actually live. A permanent base won't appear overnight, so NASA has designed a first stage lunar home called the Foundation Surface Habitat. It's a multi-level structure designed to support up to 4 people for about a month. It combines a rigid metal frame with an inflatable module. The lower level contains EVA suits, an airlock and a science station for lunar samples. The middle level is larger, around 6.5 meters wide, and houses exercise gear, hygiene systems and biological research. And the top level becomes the main living area. Sleep-in space, medical station, you've got your kitchen in there, computers and workstations. Plus astronauts themselves become part of a major experiment. How long does living on the moon change the human body long term? So if we want this base to last, inflatable modules aren't enough. We need protection against cosmic radiation, massive temperature swings, micrometeorite impacts. So ironically, the solution takes us back thousands of years. Bricks. Moon dust can be heated and baked into solid building blocks. The idea is to use an inflatable or metal structure, then encase it in a thick shell of moon bricks. That provides shielding and insulation while keeping energy levels lower. China has been testing this too. They're creating bricks from different types of simulated lunar soil. Then they sent them to the Tiangong space station to be exposed to radiation, vacuum and extreme temperatures. The bricks are expected to remain out there for years to see how well they hold up. So none of this works without power. A moon city needs energy. Solar power sounds obvious and it works for short missions, but the moon has a brutal problem. 2 weeks of daylight followed by 2 weeks of darkness. That's why solar powered missions often shut down and never fully recover. But in the South Pole region, it gets even worse. Many key zones, especially the ice-rich craters, which are in permanent darkness, they have no sunlight at all. So what's the answer? You then look at nuclear power. Nuclear power in space already exists. NASA has actually used nuclear power sources on Mars rovers. China has used nuclear tech in lunar missions, but those systems produce tiny amounts of electricity, enough for robots, not a human base. So NASA has been planning something even bigger, a compact nuclear reactor called the Fission Surface Power Project. So instead of using decaying material for small watts of energy, so this is basically true fission, splitting uranium atoms to create massive heat, then using a converter system to generate electricity. NASA wants it to be under 6 metric tons and no bigger than a car. It still needs to be huge for space, but a tiny reactor. Rolls-Royce is leading development of micro-reactors, aiming at 50 to 100 kilowatts. That's enough to power a small base, and stacking a few of these could power a whole moon base. So that's the reality. A moon base isn't just a dream anymore. It's a real engineering challenge with real solutions being designed right now. If we can figure out how to truly live, build and expand on the moon, then we unlock something huge, a permanent gateway to deep space. The moon becomes the first stepping stone, and from there the solar system gets a lot smaller. So that's the plan, not just go to the moon but build on it. The roads, habitats, nuclear reactors and eventually an entire lunar base. And the crazy part, this isn't sci-fi anymore, this is actually happening right now. So if you enjoyed this video and you want more space content like this, hit the like button, subscribe, and I'll see you in the next one guys. Thanks for watching.